In this video, we have to discuss about basics of microstrip patch antenna and how it works. First of all, the microstrip patch antenna is invented by D. Chance in the year of 1953, but practically we are using in the year of 1970s. After that, a microstrip patch antenna is reinvented by Bob Monsoon in the year of 1972. After that only, the microstrip patch antenna is very popular in mobile communications, mobile phone applications. Now we have to discuss about how microstrip patch antenna works and what are the materials are available in microstrip patch antenna. Microstrip antenna consists of three layers. First one is that bottom of the bottom layer is ground, then middle layer is that substrate, then top layer is a ground. Bottom part of the PCB, see that yellow color is there, na? This is the ground layer. Bottom part of that PCB fully copper, which act as a ground plane. Above ground plane is dielectric substrate. Substrate height is h and the permittivity of the substrate is epsilon r. Above substrate metallic strip. Width of the metallic strip is w and length of the metallic strip is L and the thickness is T. The metallic strip acts as a microstrip transmission line. This above dielectric layer metallic strip is there. This metallic strip only is act as a transmission line. This layer only is called. This layer only contain copper. Here and here no copper layer. Width of the strip much smaller than the wavelength. That width of the microstrip, this transmission line is very smaller than wavelength, and the thickness, the T of the copper transmission line is very smaller. So it is called as microstrip transmission line. Why it is microstrip transmission line means the transmission line having very smaller thickness. That thickness is in terms of micron. So it is called as microstrip transmission line. If the current is excited through this transmission line with respect to this ground layer, energy transferred from one end. The energy is transferred from one end to another end of that strip. So it is called as transmission line. When we are giving power with respect to, this is the ground layer, this one is the patch layer. When we are going that power in between ground and microstrip transmission line means that energy is goes through this transmission line. The energy is transferred from one end to another end. So this is called as transmission line. The energy are going to air. You see this second figure. When we are the energy are going to air and come back to the dielectric substrate. This field is called as fringing field. Compared to this first figure, you see that second figure. Here you have easily understand how fringing field is created. When we are applying when we are applying ground power supply with respect to ground means that transmission line is transferred from the energy is transferred from one end to another end. Due to the transmission, some fringing field is radiated. That fringing field is responsible for radiation. But in the transmission line, the fringing field is very is small. The radiation of that the radiation of the fringing field created due to this transmission line is very small, practically zero. Theoretically the fringing field in the transmission line is zero, but practically it contains some radiation. This radiation is uh, this radiation is responsible for creating electromagnetic fields. If I want to increase this fringing fields, when that transmission line fringing fields I am going to increase means what I can do means we want to increase the width of the transmission line and the length of this transmission line. And this top side of that transmission line we have to increase that length and width of the transmission line means which is responsible for antenna. See here, this transmission line is not antenna. Here only transmitting the energy from one region, one end to another end. But in this figure we have to increase that length from here to here transmission line, from this point to this point we have to increase the length and width of that particular transmission line, so that transmission line is called as patch. That patch layer is the responsible for creating that fringing field. Due to that fringing field the radiation is occurring perpendicular to this patch layer, which means that radiation pattern is creating along that Z axis. In this slide, still now what I am discussing, that point only available. And that first point, bottom and top surface contain copper gold material, which means that bottom is the ground layer and the top surface is the patch layer. This both are contain the material is copper or gold. Why we are using copper or gold means copper and gold only good conducting material. It will radiate more fringing fields. But nowadays we are using only for copper material, not use gold material because of cost effective. Compared to gold material, copper material is very less cost. Next point, middle layer as the substrate. Substrate, which is means non-conducting layer. Non-conducting layer or semiconductor. In between, in the microstrip antenna we are already discussed. Bottom is that ground layer which is contain copper, and then top layer is that patch which also contain, see this figure, top is that top of the layer also copper. In between that substrate is there. Substrate is that semiconductor layer. And then third one third point, height and thickness of the transmission line in terms of micron. See here that wait 1 second, wait, I will take The transmission line contains width and T. Okay, the thickness of the transmission line is very low in terms of micron, so it is called as a micro strip transmission line. Then fourth point, when we are applying power to transmission line, energy are going to air and compared to the dielectric. This field is called as fringing field. uh, See here in this figure, when we are up, you have to clearly visible. When we are applying that power with respect to ground means that edges only responsible for radiating fringing fields. How fringing field is radiating means, we go back to my previous video, rectangular microstrip patch antenna. In that video, I deeply discussed about fringing fields. That fringing field is radiating into air and substrate. It contains both medium, so it is called as quasi TEM mode. Then last point, fringing field. That fringing field is responsible for radiation. One more doubt you will come, why antenna is rectangular? I will tell you coming slides. We have to increasing the fringing fields. The fringing field is only the responsible for radiation. We have to increase the more radiation. We have to increase the length and the width of the transmission line. That is patch. Patch of the antenna is any shape according to your application, which contain square or circular or annular ring or rectangular patch, then elliptical or triangular. Mostly we are using patch is that rectangular and square shape. Then advantages of microstrip patch antenna. Microstrip patch antenna is a low profile. Before that, one more thing I want to discuss. For example, you have one copper wire. That copper wire, one end you have to give in the power, it will transmit to another end. It will not radiate. And then that same copper wire you have to flayed out. Flayed out means you have to bend. You have to bend means it will radiate some energy. So you have to that bending only responsible for radiation. So we have to creating radiation means you have to bend that copper wire. Similarly, you have to doing here. See, that copper wire in terms of we are frayed out like a square, circular, annular ring, rectangular, elliptical and triangular. Why this many shapes means according to our frequency range. Which frequency my antenna will radiate means for according to our mathematical calculation we are deciding that any shape. Mostly we are using antenna is rectangular and square shape only. Then advantages of microstrip patch antenna. Why microstrip antenna is most popular? Why? Because it having low profile and can be conformal. Conformal means we have to flexible. Flexible, I am telling one example. In aircraft having that cylindrical structure. In the cylindrical structure, I want to place my antenna means planar antenna is not suitable for placing in that aircraft. So microstrip patch antenna we have to bend according to our cylindrical shape. So that according to our applications, the microstrip antenna is varied and we having using different applications. Then it will fabricate very easily and you have to give that feeding technique is very easy. for like a coaxial probe feeding method or direct feeding method like insert feed technique or edge feed technique also available. Easy to incorporate with other microstrip circuit elements and integrate into systems. The microstrip antenna is actually passive device. This antenna is easy to attach with active device like amplifier or power source or filter, any other devices. You have to easily integrate with this. Then patterns are somewhat hemispherical, with a moderate directivity. Uh, the microstrip antenna contains directivity is nothing but gain D equal to neta D. Gain is around 6 to 8 dBi. Yeah, then we have to using that array antenna. Array antenna is nothing but similar antenna we have to use in that array format for increasing the gain according our applications. Then last point is it is made up of simple PCB. That microstrip antenna we have to easily fabricated. And it will support both linear and circular polarization. This last point is very important. What is meant by linear and what is meant by circular polarization means the linear polarization means only both transmitter and receiver fixed, only they are used for linear polarization, but mobile communication linear polarization is not suitable. Why? Because that mobile user cannot tell, you have to use that fixed position, we have to moving in and around and anywhere, but we are getting signal continuously. Why? Because means that circular polarization it will receive both linear and circular polarization. It will receive both vertical and horizontal signals. So microstrip antenna are mostly used in mobile communications. One more disadvantage is circular polarization is gain is very low. Gain is very low means it only used for short distance communications. Then disadvantages of microstrip patch antenna is that first point low bandwidth. Bandwidth also very low, 1 to 5% only. But we have to use defective ground structure. Defective ground structure is nothing but instead of bottom layer, ground layer is there. You have to cut some position in that ground, which means that method is called as DGS, defective ground layer structure. Clearly I am telling means we have to reduce the quality factor. We have to some portion remove from that ground layer means that antenna quality factor will reduce. Quality factor is inversely proportional to bandwidth. We have to reduce the quality factor means bandwidth is improve. Another method is we have to increase the substrate height. Substrate height we have to increase means the bandwidth also very high. Then it contains, second point, efficiency may be lower than with the other antennas. Why? Because it contains three losses. One is conductor loss, another one is that dielectric loss, then third one is that reflection loss, that is that wave loss, surface wave loss. Only that microstrip patch antenna only used for microwave frequencies and above. Like it is not suitable for below microwave frequencies, and it cannot handle extremely large amount of power. It only small amount of power, so it is well suited for mobile communications. In mobile communications, we are in mobile devices we are handling the power is very low, 3 to 4 volt, 3 or 4 watt only. So that microstrip patch antenna is very suitable for mobile devices. Then applications of microstrip patch antenna. First point is aircraft and ship applications. We have to communicate with the aircraft, one aircraft to other aircraft or aircraft to ground station or ground station to ship. We have to communicate with others means microstrip patch antenna playing a vital role in that applications. Then it will be useful for missile radar applications. Then satellite communications. Satellite communication is nothing but TV transmission and reception applications. Then mobile radio applications. Then remote sensing applications. Then biomedical. See, microwave hyperthermia is very microstrip antenna playing very important role in microwave hyperthermia and other applications like personal communications and infrared alarms, then etc. So nowadays, without microstrip antenna, no mobile devices, and not only for mobile devices, all satellite applications and aircraft application. So today microstrip antenna is playing very important role in our communications.